All right, let's talk about one of the most important and maybe most invisible pieces of technology out there. It's something you use constantly, probably without even realizing it. We're going to dive into the world of databases, so let's get right into it.
Think about it. Every single time you check your bank account, stream a show, book a flight, or even just scroll through your social media feed, yep, you're hitting a database. They are the hidden engines that power pretty much our entire digital world. But what exactly is this thing that holds it all together?
Okay, so let's start at square one. What is a database, really?
Probably the easiest way to wrap your head around it is with an analogy. Picture a huge, perfectly organized library. It's not just a random pile of books, right? It's a system. Every single book has a specific shelf, a catalog entry that tells you where it is, and a process for checking it out. A database is that, but it's a digital library for information.
But before we can have a library, we need the books. And in our world, the books are data. And data is really just a raw fact. Your name, that's data. The price of a cup of coffee, that's data too. It's any known fact that you can record.
And that's where the database itself comes in. It takes all those raw individual facts and it gives them context. See, it's not just a random jumble of information. It's a collection of related data. It's built to represent a specific slice of the real world, what we like to call a mini-world. That could be a university, or a hospital, or an online store.
So how does all this work? I mean, you can't just throw data into a folder and hope for the best. You use what's called a database management system, or a DBMS for short. And if we go back to our analogy, if the database is the library, then the DBMS is the master librarian. It's the software that knows exactly where everything is, who's allowed to see it, and how to keep it all tidy and secure.
In this diagram here, this really pulls it all together. You can see at the top you've got us, the users, and the apps we use. We send a request. That request doesn't go straight to the data. It goes to the DBMS software, our librarian. The librarian then goes and finds the exact piece of data we need and sends it back. This whole setup, the apps, the software, and the data, that's what we call a database system.
Okay, enough of the theory. Let's make this feel a bit more real. We're going to build a really simple database for a university, just to see how all these pieces actually work in the wild.
So our mini-world is a university. Now, the main things we need to keep track of, what we call entities, are the students, the courses, the instructors, and the specific sections of each class. But, and this is super important, we also have to track the relationships between them, like which student is taking which section or which instructor is teaching it.
So, first up, we make a table for our courses. And look, it's pretty simple, right? It's basically just a spreadsheet. Every row is a different course, and each column gives us a specific detail. Its name, its number, how many credits it's worth, and what department it's in.
Okay, next piece of the puzzle. Here's a table for the specific sections of those courses that are being offered. But, did you spot it? Look at that course_number column. That is the magic link. That's how our database knows that Section 92 is the Fall '04 instance of Intro to Computer Science, CS 1310. We're starting to build those powerful relationships.
And here's where it all comes together. This grade report table, it doesn't bother with names or course titles. It just links student number 8 to section identifier 135 and says the grade was an A. The real power is that the DBMS, our librarian, can instantly zip across all these tables, follow those links, and tell you the full story. Student 8 got an A in the database course. That's the whole idea behind a relational database.
So, we get the technology, but who's actually using all of this stuff? Well, as it turns out, there are a few different types of people who interact with these systems. You know, most of us are what you'd call naive users. It just means we're using an app to do something. We're performing a pre-programmed action, a canned transaction like getting cash from an ATM. Then you have your casual users. Think of a manager who pulls a sales report once a week. And finally, you have the sophisticated users, like scientists or engineers who are writing their own complex queries to really dig deep into the data.
And then, of course, you have the people working behind the curtain, the architects. The database designers are the ones who create the blueprint. They decide what information to store and how to structure it. And the database administrators, or DBAs, well, they're the ones who keep the whole system running, managing security, giving people access, and just making sure everything works.
So, you might be thinking, okay, this seems kind of complicated. Why go through all this trouble? Why not just use, I don't know, a bunch of spreadsheets? Well, the answer is that the database approach has some incredibly powerful advantages. There are really four big ideas that make databases so special. First, they're self-describing. The database actually contains its own map of what's inside, called metadata. Second is program data independence, which means you can change how the data is stored without having to rewrite every single app that uses it. Third is abstraction. It hides all the messy technical details from the end user. And finally, and this one is huge, is concurrency control. This is what lets 100 people book a plane ticket at the exact same moment without the airline accidentally selling the same seat twice. It's absolutely crucial.
And all of that leads to some massive benefits. You can control redundant data so everything stays consistent. You can restrict access, which is obviously vital for security. You get things like automatic backup and recovery. You can enforce rules to keep the data clean. And like we saw with our university, you can model really complex relationships in a very clean, elegant way.
Now you've got to understand, the world of databases hasn't been standing still. Not at all. It has evolved like crazy over the past 60 years to tackle some incredible new challenges.
It all really kicked off in the 60s, but the real game changer was the relational model in the 70s. That's the foundation for most systems we still use. The 90s saw some different ideas pop up, but the next true revolution came with the 21st century and the internet. The unbelievable amount of data from social media and online shopping created this whole new field called big data, and a new kind of database called NoSQL.
And this slide, I think this just perfectly captures that shift. We went from managing neat and tidy numbers and text to trying to manage the beautiful chaos of social networks, photos, videos, map data, and these giant data sets we now just call big data.
The scale is just, it's hard to even imagine. A petabyte is 1,000 terabytes. It's 1,000,000 gigabytes. And some systems out there are handling that much new data every single day. This is the kind of challenge modern databases were built to solve.
And that kind of brings us to one final and pretty critical question. We've talked about what databases are and how they work and how they've evolved. But as these systems truly become the foundation of our entire society, storing everything from our personal messages to our medical records, the question of who gets to design them, who controls them, and who secures them, well, that becomes more important than ever. Something to think about. Thanks for joining me.